Alright, so here's a video of how to do the elevator problems. Alright, so let's say here's the elevator, and then we like to draw the free body diagram of this elevator. And we all know what free body diagram is. It's just like you label all the forces acting on the object. So if we say this elevator is moving, let's say initially like this elevator is at rest. What are the forces that's acting on the elevator? Alright, so if the elevator is at rest, the net force is zero, right? But net force is zero does not mean that the thing is not that it has no force acting on the object. It's just that all the forces cancel out. So think about it. So the elevator, of course, there's a force of gravity to it. So there's a force of gravity. But since the elevator is not moving, it means all the forces cancel out. So there has to be a force of tension on the string that's hanging the elevator. And these two forces should be equal or exactly opposite, but like equal in equal in length, equal in magnitude. So let's say in another case this elevator is actually moving down by a velocity of let's say moving down in the it's moving down in a velocity of, let's say, 5 meters per second in the constant velocity. So what is the force acting on the thing? Well, this thing is not accelerating. So I mean, since the elevator is not accelerating, so all the forces acting on the elevator has to like cancel out, or like net force is actually zero. So a lot of people don't understand it again. Like, why isn't this thing not? Why is there no force acting on it? If even though the thing is moving, well, the thing is moving, but it's not accelerating. If there's a force acting on an object, this object moves faster and faster. But in this case, is maintaining its own motion, and then it's not getting faster, or like the direction do not change, like nothing changes, so there is no net force acting on it. So again, in this case, if it's moving downward in the constant velocity of anything, there is a force of gravity and there is a equivalent force of tension. So let's say in another case, let's say the elevator is accelerating down, for let's say 5 meters per second square, accelerating downwards. So in this case, since it's accelerating down, so then the downward force has to be bigger than the upward force. So this Fg is actually bigger than Ft. Right. So we say if the elevator is accelerating upwards of acceleration of 5 meters per second square, well, this elevator, this upward force has to be bigger than downward force, so it will be like this. So like it's really easy to think about like how many forces are acting on the object, because here clearly there's a force of gravity is pointing down because we feel the gravity, and then there's another force of tension that's like tying it up, so this elevator does not free fall. So if I cut the string off, of course this is not like just free fall. If I cut the string off, then the only force acting on it has to be Fg, and there is no Ft. That's why it's like straight up falling down. Alright, so yeah, that's like everything I have to say about elevator, and I know this is a short video, but yeah, elevator problem is like one of the typical problems, so yeah, that's it.